Okay, thank you very much. Good afternoon to everybody. First of all, I would like to express my thanks to Professor Ben Abraham for being kind to invite me here to Haifa to give a talk about the oil spill modeling issues we are doing in the Mediterranean. And of course, it's the good cooperation we already start with the team of Professor Ben Abraham following the symposium on the Eastern Mediterranean we had last week in Limassol. And of course, we are looking forward to extend this cooperation through project funded under the Horizon 2020 or other opportunities from European projects. So it was also mentioned by Professor Ben Abraham. In a case of an oil spill in the size or similar to that case in the Mexican Gulf in April 2010, then the oil spill, will not know any boundaries. So this may affect the entire region in a case that this will be happening. So for the Mediterranean, the last 3 years, we are running a project funded by the MEDESS program in order to establish a service, in order to assist the response agencies in a case of major oil spills in our area, taking in account the developments on the oil and gas industry happening in the Levantine Basin. So in my talk, I will also brief you about the developments carried out with Europe and also the Copernicus, the former Global Monitoring for Environment Security, then the motivation why we need to have operational oil spill models, and then some example, in particularly the Mediterranean exercise on pollution, about the project itself, and some application we had done from planet risk assessment from planet installation of offshore platforms in the Cyprus EZ, and some conclusions. So in Europe, the last 10 to 15 years, it was an initiative to develop several services in order to strengthen and support the member states in respect to the atmosphere, land, or ocean, across the boundaries and for emergency. These activities were carried out in the frame of global monitoring and environment, but the last 2 years it was renamed to Copernicus. So the aim of this initiative is to establish 6 services, one of which is the marine service, in order to provide on a daily basis information about the seas, about the sea currents, about the sea state, temperature, and any other information that is very necessary to be used for further downstream applications. So here we have, just a minute right here, we have the world famous butterfly of this GMES on marine services. So to the left, we have the production services, so the data coming from various resources, like satellites or like forecast system under a project, the most famous one, and it's a MyOcean. To the right, we have the downstream application, like the oil spill prediction, which these services they are using in order to be implemented, data coming from these, say, core services. So this Copernicus Marine service provide daily information about this globally, about the sea currents, temperature, salinity, about the sea level, and in addition biochemical information like the chlorophyll productions, nutrient concentration, and so on. And of course, we have, in addition to the global, we provide in 6 regions, among of which is the Mediterranean. This information available, I said, every day, from the surface to the sea bottom, anytime, and also through the years we have established, say, a climatological database for the last 20 years. So someone can go and use this information from the last years too. Further, this information it is used for further downscaling application where, for example, Israel, Oceanographic Institute, as well Cyprus, and other nations in the Mediterranean, they have downscaled all this information with a high resolution, providing a better resolution for the needs of the coastal country. So now, why, all this information it is needed? Because in order to support the response agencies in a case of a major oil spill incident, you need to have all this information about the sea currents, the waves, etc., the winds, etc. The coastal countries, knowing the problems with the ship traffic initially, and in the Mediterranean, and nowadays, of course, with the oil and gas industry going on in our area, in the neighborhood of the Levantine Basin, they prepare themselves in order to respond in a case of a major oil spill incident. They have carried out periodically exercises, communication, exercise with equipment, ships, and deployments of bombs, and several other activities. However, the first following the contingency plan. They have a certain contingency plan with certain, say, instruction and guidelines, what they had to do. They need, the first information they need in a case of a report of an oil spill is information about the prediction of the movement of the oil spill. So the same thing is also, it is requested by REMBEC. REMBEC is a regional emergency response center for the Mediterranean. It's an IMO organization under UNESCO, and they also request this information about the prediction, and also they need information about to identify, in the case of oil spill coming from ships, who is responsible, because there are some European rules and regulations, particularly the 2005-35, where it is required request from the member state to identify the responsible of the oil spill and bring this to the prosecution. So the use of the oil spill modeling predictions, and particularly during operational issues, it is necessary in order to provide answer to three main questions requested by the responsible agencies. Is just where the spill will move, how soon the spill will go there, and which resources we're going to threat at then when it will reach the coast particularly, or an offshore structure. And of course, there's an additional information needed by the response agencies when they had to decide the way to combat the oil spill. Is they need information how the oil spill will like when it arrives in a certain place, because the oil spill is changed the viscosity, is evaporated, and so emulsified. So all this information is vital in order to decide the exact measure. Either they have to use booms, mechanical recovery, or they have to do a spray. So for the first three questions, in order to provide this information and the answers to the response agencies, we need to have in place accurate and reliable information about the sea currents, wave, temperature, winds. And all this information is provided by the Copernicus Marine Service and the National Ocean Forecast System, as I said before, like one that is running in Israel Oceanographic Institute, in Cyprus, and several countries. So because it was necessary to address this on a Mediterranean scale, so to establish a service that will be served for all the nation, no matter they are member states or non-member states, and in addition to provide an information that will base on a multimodal approach. So not going to use only one system, but the capability to use several, information forecasting system coming from different systems, and at the same time using at least several or a few well-established oil spill models. So we have established this project. We got this project 3 years ago, as I said, in the frame of the MEDESS program. And it is dedicated to the prevention of the maritime risk and to strengthen the maritime safety in the Mediterranean coming from threats of the oil spill. And as I said, this provides an integration of all this information in one system, and this system will be available, and is available already, to all the Mediterranean countries, and particularly also to the REMBEC, that is an organization that provides guidance information to all the Mediterranean countries, as well as to EMSA. EMSA is the European Maritime Safety Agency. So in the project, we have 21 partners. from all the Mediterranean, but unfortunately, Israel is not, say, participate in this MED program because they didn't contribute as a country. So it was not able to have the partner for this project in these activities. Nevertheless, the service, it is available to all the nations in the Mediterranean. So the service was established based on the existing experience of all the people participating in the project, and of course it was based on the well-established forecasting system and the oil spill in the Mediterranean. Within this project, we have we are available on a daily basis information from coming from 9 different Mediterranean forecasting centers, and also from 20 providing also 20 different data sets covering the sea currents, the ocean data, sea temperature, waves, atmospheric from 7 forecasting systems, and covering all these systems various either the entire Mediterranean or regionally or coastal with different resolutions. So all this data, they are harmonized and they are available through a network data repository in order to be used in any time. So from this table, you can see that all these data are available. They have a common format, input, output, specification, file naming, and so on. So are available to all the countries, and they can use this for for example, for real applications, or in case they want to do a hindcast application to identify, for example, where an oil spill will going to affect and which area. And all this information, it is handled through a network data repository where they integrate all this information and avail this to the oil spill models in a case of an oil spill incident. So this service is provided through a user interface from where the user can run the system manually. So he can go and choose the forecasting data, I mean the ocean data, the waves, the atmospheric data, and of course to choose the oil spill model. You can run simultaneously 2 or 3 oil spill models in the same time, and then all this information is available to him. At the same time, the system is able to run automatically in the case that there's information coming from the satellites. I will show later on. Here, for example, is some application of the service where we have used the same oil spill model. In this case, we have used the Poseidon oil spill model with different ocean forecasting data. To the left, you can see a high resolution sea current. The oil spill is hypothetical, of course, in this case. It is offshore the EZ of Egypt. And to the right is a use of lower resolution forecasting data, where you can see that the benefit of high resolution sea current data is best compared to the lower resolution. The data with high resolution in that case is coming from the Cyprus forecasting system, where the right one, the lower resolution, from the Mediterranean forecasting system. Then a second example is in the Central Ionian Sea, where in that case we have used different oil spill models with the same ocean forecasting data. So in this case, when more or less the spill, it is following the same flow path because we are using the same data. This also it is indicate that more or less the well-established oil spill models, they are good enough to be compared between them. Then, as I said before, the system is able to use satellite information detecting oil spill, possible oil spills, and to be run automatically for a certain period. And in addition, also you can run the system backward. So in the case that you have observed from a satellite an oil spill now, then you want to know from where it came. And then you can integrate with the traffic, with the ship traffic, using the data coming from the AI system, the automatic identification of the ship. And in this way, you can have information which ships it was closer to the oil spill that it was predicted backward. This is a pre-requirement for the project. So then we had in December 2013, that means that 11 months ago, an exercise carried out within the project, but led by REMBEC, where all the representatives of the response agencies from all the Mediterranean countries, from Israel too, and from all the rest countries, they participate. And in that case, it was requested from our MEDESS service to provide, in the case in the Levantine Basin, of prediction of oil spill from a blowout from 1,000 meters from a well, from existing well in the EZ of Egypt, and to run the model for 50 days. So you can see to the right the vertical bloom of the oil spill from 1,000 meter depth. You can see that it is variated because of the variability of the sea currents, and of course it is also is not vertical because you have the subsurface currents. To the left animation, we have the surface distribution of the oil, while to the middle we have the subsurface, the oil spill that is below the sea surface. And to the right, you can see is the oil that it is permanently stuck on the coast. And the most important for this application, we ran this in December for 50 days, so it was December and January. You can see that the highest concentration in this particular application affects the Haifa Bay and mostly the area north and south of Haifa. So this is an important findings, and that the response agency had to take into account. Also to the bottom right graphs, you can see that the red line is indicate the surface concentration, and from the time that the oil spill start to stuck on the coast, the surface oil it is reduced, while the subsurface oil concentration in the water column is increased. And then, of course, we are requested to do a risk assessment from 10 planet offshore platforms in the EZ of Cyprus. You can see to the these left maps with the yellow dots represent the 10 locations that any Cyprus is going to drill, and then if they will find gas or oil, they are going to establish the platforms. So there was a request from them to provide long-term forecast using historical data. So for this application, we have used and they run the system for 4 years. We initiate the system every 15 days. And we have producers from all the different 10 locations, images in respect where the spill will move in certain periods and from the different locations. And of course, in addition to indicate and to provide information, the first impact on the coast. So to know exactly, based on the historical data from this location, which coastal area would be affected in that particular period. So we have run the system here. I think we produce more than 1,200 scenarios in order to, just as an example here. And then, of course, in continuation of this risk assessment, we have also, it was requested to provide from each location the area will be affected by during the first, second, fourth, and so on days of the oil spill predictions, and in addition to identify the exact day and time when the oil spill will expected to reach the coast, and then also to calculate the length of the kilometers of the coast will be affected by the oil spill from the different locations. So concluding, I have two conclusions. First, the roles of this service, that it is already in place. And particularly of the oil spill system we developed in Cyprus, and it's also used by our friend and collaborators from the Israel Oceanographic Institute, MEDESS, becomes important in this risk assessment from the offshore platforms coming in our neighborhood. And I think that it is necessary to take in account for any design and before to start to drilling. In Cyprus, particularly, they take in account before the authorities they will grant the permission to Noble or to Eni or to Total to do any drilling. They had to have in place, in addition to these environmental studies, also information about the predictions of possible prediction of the oil spill. In this particular image to the left, you can see an example of the oil spill dispersion from the Aphrodite platforms. It was done last year, and it was in a case when we have a very strong anticyclonic eddy in the area, that it was capture the oil spill within the eddy center, not allowing it to reach the coast. And conclusion B, it is, of course, and before the oil and gas activities in our area, it was very heavy traffic by the ships, tankers, going up and down from the Suez mostly, but also in the Latakia in the Gulf of the Iskenderun. So to the left, this is a satellite image using data coming from ESA, the European Space Agency, as well as from EMSA, where we have identified more than 1,000 possible oil spill in our EEZ. And of course, to the right is main ship traffic. So this information is vital in order to know if a case, an oil spill will be happen, to know if and when it will be affect our coastal areas, in order that the response agencies, they will take the appropriate measures. The service is in place. And early in December, I think it's between 8 to 10, we're going to have a sub-regional training to the response agencies on how to use the service. And I take this opportunity to invite all the interesting people of the responsible agencies maybe here to attend this training that will take place partially in Limassol and then in Nicosia. Thank you very much.